Hello dear students, in this video we are going to study a very basic topic of digital electronics, that is binary number system. What is the need of this topic? We know that we are living in the era where we are living in the digital era. Okay, so in order to learn these digital machines, we need to learn their language. That their language is binary language, which consists of zeros and ones. In order to program these machines, in order to learn about these machines, we know the basics of the language which these machines are using. Okay, so for this topic is particularly useful for all the computer students, electronic students, those from faculty of BSc, that is science, engineering, BTech, or all. This topic is also beneficial for the students who are appearing for the different competitive exams. Okay, so this is one of this language consists of zeros and ones. Now when we study any language, or when we study any number system, we should know the base of that number system. What do you mean by base? Okay, when the number of symbols any language use is known as base. For example, just start with the number system which is familiar to us, that is decimal number system. Now decimal number system we are using, so that number system uses the symbols 0 to 9. Any number in decimal number system can be formed using these symbols only. From 0 to 9, total 10 symbols are there. That's why this number system is said to be having base 10. Base is also known as radix. Base or radix. It's important part of any number system. I think the base is clear, or the radix term is clear. Okay. Now for binary number system, as this number system uses only two symbols, 0 and 1. So the base or radix of the binary number system is nothing but 2. Okay, base of or radix of the binary number system is 2. Now in this topic we are going to study the interconversion of binary number system with decimal number system. For example, now we'll take one example of one decimal number, 243. Okay, now in 243 I can write this decimal number this way also, 243, and this is the way of representation of any number system. If I am having a number in binary, this number, just don't bother about what is the value of this number. Just this is a string, or this is a binary number, so I can represent this with the help of this. There are different number systems which we are going to study in our next lectures. Octal number system, hexadecimal number system. So in octal number system, as the number of symbols are 8, so here we have to write 8. In hexadecimal, the total number of symbols are 16, so we will be writing 16 here. Okay, that will be covered in next lectures. Now coming back, in decimal number system, 243, this is a decimal number. Now every number system has got certain weight associated with it. Okay, now for example, this digit, this is the least significant digit, this is the most significant digit. Now this least significant digit is having the weight which we can write 10 raised to 0. As this is decimal number system, we are writing any digit, or every digit is associated with the ascending power of 10 raised to 1, then 2 into 10 raised to 2, right? So that's why we can write here 3 plus 40 plus 200, right? So the thing is, what I want to tell you here is that as this is decimal number system, so the weight or the every digit here is associated with 10's power. Now if we study binary number system, okay, so in binary number system, for example, I am taking this number only. In binary number system, again one important thing is that every digit is known as bit, because binary digit, that is bit, So every digit is known as bit. This is LSB, least significant bit. This is MSB, that is most significant bit. Okay, so again, as this number system is binary, its base is 2, so I can write this thing in ascending power of 2. This 0 into 2 raised to 0 plus 1 into 2 raised to 1, this plus 0 into 2 raised to 2 plus 1 into 2 raised to 3. So it will be, if you see 2 raised to 0 is 1, so 1 into 0 plus 1 into 2 plus 0 into 4 plus 1 into 8. Okay, so it will be 8 plus 4 into 0, that will be 0 plus 2 plus 0. So that will be 10. That will be 10. So I can write 10. And 10, we can say that this number 1010, which is in binary, that is same as number 10 in decimal, or 10 is decimal equivalent of the binary number 1010. So this way we have what we have done here, we have converted the binary number into decimal number. This is the method for converting binary number into decimal number, right? I'll take one more example to get it more clear. Take one number 1111. This is binary, so I will be writing this way. I can represent this way. Now this 1, so 1 into 2 raised to 0, you have to write in ascending power of 2 raised to, then this 1 into 2 raised to 1, then third one into 2 raised to 2, and this fourth one MSB, that is 1 into 2 raised to 3, right? So 8 into 1, that is 8, 4, 2, 1, it comes out 15. So it is decimal 15 is the decimal equivalent for this binary number. Thus we have converted binary number 1111 into decimal number, and the answer is 15. So any number in binary you can convert this way using the 2's power, right? Because the base is 2. Now we'll do the opposite. Now we will convert any decimal number into binary. So let's take this number only, 15 number. If I want to convert this into binary, what to do? So in order to convert any decimal number into binary, we follow a method known as double-double method. Double-double method, or it is also known as divide by 2 method, because here we are using, here we are dividing the numbers, we keep on dividing the numbers by 2. That's why it is known as divide by 2 method. Now the decimal numbers which we want to convert it into binary is 15. Okay, so what we have to do, we have to write the number first, we have to write these vertical lines and this way, then we have to keep on dividing this number by 2. Okay, here you have to write the quotient part, here you have to write the remainder part. Okay, now if I divide this number 15 by 2, the quotient what I will get is 7, and then 1 will be the remainder. Now keep on dividing the quotient by 2 till we get the remainder 1. Okay, so 2 3s are 6, again quotient is 3 and 1 is remainder. Now again 2 1s are 2 and the remainder is 1, quotient is 1. Now once we get the remainder quotient 1, now this quotient, this 1 cannot be divided by 2. So what we have to do is, we have to shift this number here. Okay, now this part, this remainder part we have to consider, and this part is only the part which is important to us. So we have to go, it's again important, last but not the least, we have to go from bottom to top, and we have to follow the sequence from bottom to top, 1 1 1 1 1 1 1 1. So this is the number we are getting for decimal number 15. This is the binary equivalent, or this is the binary number which we are getting for 15 decimal. Now we can cross check that. Here also what we have done earlier in the example, what we have done, we have converted the decimal number into binary and we have got this number. Now we have done what we have done now, we have taken the decimal number and we have converted that into this. Earlier what we have done, we have taken the binary number and we have converted that into decimal, and that time we have got the 15 answer. Okay, so we are just verifying that thing. Okay, we can take one more example. For example, take this number 24. Take the number 24. Okay, divide by 2 method we have to follow. We have to keep on dividing the number with 2 by 2. 2 12s are 24. You have to write quotient here, you have to write remainder here. Remainder will be 0. Then 2 6s are 12. Remainder will be 0. 2 3s are 6. Remainder will be 0. Now 2 1s are 2. Quotient is 1. Remainder is 1. Right? Now we have to keep on dividing until we get 1 as the quotient, because now 1 cannot be divided by 2. We have to shift it here. And then the last step, that is we have to go from bottom to top and take the sequence from bottom to top. So the sequence will be, what will be the sequence here? 1 1 0 0 0 1 1 0 0 0. So this is the binary equivalent which we have got for the decimal number 24. So we can represent this way, 1 1 0 0 0. Okay, so this way we can convert any decimal number into binary using double table method, and any binary number into decimal. Okay, so this is all about the interconversion of decimal number system.